Hey guys, so today we're going to be doing another example for related rates, and this example is a very popular one. It is the ladder problem. Like I said in my first video on related rates, I'm not doing these videos so you guys can, memorize case by case examples, but so you guys can get a hang of, related rates problems and how you should work through them. So it's better to get a general idea of, how to deal with these problems and understand what we're doing rather than trying to memorize situations. So let's get into this one. So what this problem says is that we have a 20-foot ladder resting on a vertical wall. If the bottom of the ladder is sliding away from the wall at 2 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 5 feet from the wall? Now, at first glance, like many related rates problems, you might be like, wait a second, how am I supposed to know this? Somebody on the street, if you just showed them this, they'd probably answer, it's probably 2 feet per second as well. But that isn't the case. So, you know, these problems they sound weird, but they have a lot of these related rates problems. They're word problems. They're real life situations. So, um, a lot of people ask when will I ever use math. Well, you're seeing it right now. So, well, the first thing we should do is draw the situation. So we got our ladder, and we got our wall, and we got the ground. And so let's label everything. The first thing you should do in many related rates problems is to draw a diagram, draw a picture, and just label everything. And so the easiest thing to label here is, well, the length of the ladder. And I'm going to call this R. So the length of the ladder is R. And, well, let's model the situation. So what the problem is saying is that this ladder was vertical along the wall and then it starts sliding downwards. So the bottom of the ladder is sliding this way and the top is sliding downward. So let's fill in the rest of the information. Well, but before we do that, let's define. Let's assign variables to the wall, you could say, and the ground. We could think of these as the x and y axes. You could pretend that this ladder is laying on the x and y axes in the Cartesian plane. And you could think the y-axis is the wall and the x-axis is the ground. And, this is a good way to model this situation. It's kind of more familiar. Rather than just thinking of a wall and the ground, you think of the x and y-axes, and this ladder is leaning against both of them. And so let's fill in our information. So we want to find out how fast the top of the ladder is going downward when the bottom of the ladder is 5 feet from the wall. So that's another piece of information. X is 5 feet. Okay, so we also know one more thing. Dx by dt. How fast the ladder is moving away, the bottom of the ladder is moving away from the wall, is the change in x with respect to time. And we know that is 2 feet per second. Just put those units in there. Okay, so we know that. So what are we looking for? Well, we're looking for dy by dt, right? Related rates. We're looking for this. And, well, are we missing anything else? Well, we don't know this either. So it's really nice, especially if you struggle with related rates problems, is to draw a diagram and label what you know and label what you don't know. And another one. Well, we have dy by dt, dx by dt. What about dr by dt? what is dr by dt? You know, is this quantity even changing? No, because the ladder will always be 20 feet. The ladder's length is not changing. Yes, it is sliding, but that means x and y are changing. The ladder doesn't stretch or compress itself. It's always going to be the same length. So dr by dt is always going to be 0. The length of the ladder never changes. It's always good to, draw a diagram and really imagine the situation in your head and, put it in physical reality. Like, will the ladder really, expand itself? And that's why, you really got to get these critical thinking skills that you got to be able to, visualize situation, make it realistic, put it in physical terms, and go from there. So drawing a diagram can really help with this. And look, all of our information is clearly laid out, and we can just, figure out each different aspect. And the first aspect we should be, trying to figure out is, well, what is y? Not dy by dt, but what is y itself? But actually, before that, we need to realize, we need to connect x and y in order to connect dy by dt and dx by dt. Remember, related rates, we are looking for a related rate of change in terms of another related rate of change, of another variable. So what we have to do now is realize the situation. And what situation do we see here? Well, it's quite obvious, is that we have a triangle. We can use the Pythagorean theorem. So x squared plus y squared equal to r squared. The first thing we should do is figure out what y is, because, in order to get dy by dt, we need to know what y is. So let's do that. Not hard, just plug in our numbers. 5 squared plus y squared equals 20 squared, and then y would just come out to be the root of 375. And it's good to use exact values rather than just using decimal numbers on your calculator. In calculus and math, it's usually preferred you just use the exact value. So we got our value for y, so check, we got this. Now let's actually do what the problem is asking, which is find dy by dt. How fast the ladder is sliding downwards. The top of the ladder is sliding downwards, specifically. So let me just erase this. Well, we had a relationship. Right? We have a triangle, we have the Pythagorean theorem, and in order to find dy by dt, well, we need to take the derivative with respect to time of this equation on both sides. So let's do that. So we use the chain rule, so 2x times dx by dt. And I recommend writing dx by dt because it reminds you that you're taking the derivative with respect to time. So dy by dt. And recall that the length of the ladder is never changing. Therefore, the derivative on the right side of the equation is just 0, because the length of the ladder is not changing with respect to time. So what are we left with? Well, we've got 2x times dx by dt plus 2y times dy by dt. And all we have to do is just fill in the numbers. So 2, what is x? Well, x is 5. What's dx by dt? Well, that's 2 as well. Plus, what's 2y? Well, y was just the root of 375. There we go. Times dy by dt. And that's what we're looking for, right? So just before I finish this question, what I want to say is that you're looking for a relationship that relates the rates that you are given. So here we have dx by dt, and we want to relate that to dy by dt, and in order to solve for dy by dt. So it's important to draw a diagram. Imagine the situation. Just think about the situation, realizing that the length of the ladder is not changing. It'll always be the same. It's a ladder. It's not going to stretch or compress. It's just going to be the same. And it's sliding down, and just imagining this in your head. You got to be really visual with these related rates problems. And you got to draw a diagram and just fill in the information. And, sometimes you might not need all the information. And, if we could have just left this, we could have found y after. We may have not needed it, who knows. But sometimes you come across, sometimes fill in extra information, and that's fine. I guess you could differentiate first and then fill in the information if you like, but here I just wanted to, give you guys like a clear cut way of, approaching this and, just thinking about it. So let's finish this off. Dy by dt. And so this turns out to be negative 20. This is just divided by 2 root 375. Just write that, 375 feet per second. Now, some of you guys might be thinking, well, why is it negative? Well, the ladder is moving in the negative direction. It's moving downwards. The top of the ladder is moving downwards. Therefore, we have a negative sign. The top of the ladder is moving negative 20 divided by 2 over 375. Root 375 feet per second. Because it's moving in the negative direction. And if you've taken physics, this is nothing new to you. Because, you learn this and you get an idea of this, that if it's moving in the negative direction, we define, downward as the negative direction. Therefore, since it's moving that way, its displacement is in the negative direction. Therefore, dy by dt is going to be negative. So I hope you find that useful.